Welcome to MRL. In this learning session, let us find out the values of trigonometric ratios for some specific angles. The angles considered are 0 degrees, 30 degrees, 45 degrees, 60 degrees and 90 degrees. Let us begin finding out the values of T ratios of 45 degrees. Now let us consider triangle ABC. Now triangle ABC is an isosceles right angled triangle. That means angle B is 90 degrees and AB is equal to BC, that is equal to 1. Now since angle B is 90, it is isosceles triangle, the base angles are equal, therefore angle A is 45 and angle C is also 45. So let us consider angle A, which is equal to 45 degrees here. By applying Pythagoras theorem, we can find out AC square is equal to AB square plus BC square, that is 1 square plus 1 square, and that is equal to 1 plus 1 2, therefore AC is equal to square root of 2. Now let us go for, with the help of definition of trigonometric ratios, let us find out the values of trigonometric ratios for 45 degrees. Now sine of 45 degrees here, sine A, angle A, that is sine A is 45 here, so for sine 45 degrees is equal to BC upon AC, that is 1 upon root 2. So therefore we have sine 45 degrees as 1 by root 2. Now let us go for the cos 45 degrees, that is cos 45 degrees is AB by AC by definition, and therefore it is again 1 by root 2. Let us go for tan 45, that is BC by AB, that is 1 by 1, and that is equal, tan 45 degrees is equal to 1. Now cosec 45 degrees, you take the reciprocal of sine, it will become root 2. Sec 45 degrees, take the reciprocal of cos, it will be root 2, and cot 45 degrees, reciprocal of tan is 1, and therefore we have the values for trigonometric ratios of 45 degrees. Okay, remember, I will learn how to remember this. Okay, so when we learn all, then we'll try to draw a chart and learn how to remember this. Now coming to the next important values of trigonometric ratio, that is trigonometric ratios of 60 degrees. Now let us consider a triangle ABC. Mind you, we need 60 degrees, therefore I have taken an equilateral triangle. So triangle ABC is an equilateral triangle in which AB, BC and AC, all the three sides are equal to, I have taken it as the length of the measure of the sides as A. Now AD is a perpendicular, it is a perpendicular bisector, and we all know a perpendicular bisector AD drawn in an equilateral triangle bisects the base BC, and therefore CD is A upon 2. Now let us consider an angle 60 degrees here. As we know, the angles of an equilateral triangle are all 60 degrees. We have angle A as 60, angle B as 60, angle C as 60. So let us find out the length AD. The length AD, that is AD, we have to find out by Pythagoras theorem. So in triangle ACD, in triangle ACD, we know that AC square is equal to AD square plus CD square, or AD square is equal to A square, or A square minus A by 2 whole raised to square. That is already written here. When we simplify it, we get AD square is equal to 3A square by 4, or AD is equal to root 3A square by 4, or is equal to root 3 into root A square by root 4, that is equal to root 3A by 2. That means we have the value of AD as root 3A by 2. So try to find out this length AD. We require it because we have to find out all the trigonometric ratios by their definition. Now let us go to find out the values of trigonometric ratios for 60 degrees. For 60 degrees, let us find out the sine 60 degrees first. So sine 60 degrees, when we take the triangle ADC, for sine 60 degrees, it is the opposite side upon hypotenuse, that is AD upon AC. AD upon AC, that is root 3A by 2 divided by A, and we get root 3 by 2. Therefore sine 60 degrees is root 3 by 2. Now let us go for cos 60 degrees. We know that by definition cos 60 degrees is equal to the base upon hypotenuse, that is CD upon AC, and that is A by 2 divided by A, and that is equal to half. So therefore cos 60 degrees is 1 upon 2. Now let us go for tan 60 degrees. When we find out tan 60, it is by definition opposite side upon base, that is AD upon CD. AD is root 3A by 2 and CD is A upon 2, and therefore when we simplify, we get tan 60 degrees as root 3. So we have sine 60 degrees is root 3 by 2, cos 60 degrees is 1 by 2, tan 60 degrees is root 3. So these are the values of trigonometric ratios for an angle of 60 degrees. Now let us go further. We take the reciprocal of sine 60, we will get cosec 60, therefore it is 2 by root 3. Cos 60 degrees, we know it is 1 by 2, take the reciprocal of that, that is 2. Tan 60 is root 3, therefore reciprocal of that will be cot 60 degrees, and that is 1 by root 3. So that is how we find the the values of trigonometric ratios for 60 degrees angle. Now let us go for finding out the trigonometric ratios of 30 degrees. Now in the same triangle ABC which we have learned now for 60 degrees, now when I have drawn a perpendicular, you know that it is also angle bisector. It divides the angle A into two equal angles. Therefore angle CAD is 30 degrees. CAD is 30 degrees. We already found out AD, that is root 3a by 2. Now we have to go for sine 30 degrees. So in triangle ACD we have to take this angle as 30 degrees. So for sine 30 degrees it is opposite side upon hypotenuse, that is CD upon AC, and that is A upon 2 divided by A, and the answer is half. Therefore sine 30 degrees is half. Now let us go for cos 30 degrees. It is by definition AD by AC, because the adjacent side divided by hypotenuse, AD by AC, that is root 3a by 2 divided by A, and by simplification we get cos 30 degrees as root 3 by 2. Now let us go for tan 30 degrees. It is opposite side upon base, and that is CD upon AD, and that is equal to A by 2 divided by root 3a by 2, that is 1 by root 3. Therefore tan 30 degrees is 1 upon root 3. Now taking the reciprocal of sine 30, we get cosec 30, that is 2. Reciprocal of cos 30 is 2 by root 3, that is sec 30 degrees, and reciprocal of tan 30 will be root 3, that is cot 30 degrees. So these are the trigonometric ratios of 30 degrees for 30 degrees angle. Okay, remember that. Now coming to the trigonometric ratios of 0 degrees. Now this is very interesting here. Now here angle A is 0 degrees. If I make angle A 0, then C coincides with B. Rather BC becomes 0 and AB will be equal to AC. So with this understanding, let us start finding out the values. Now sine 0 degrees is equal to BC upon AC. BC upon AC, BC is 0, therefore sine 0 degrees becomes 0. So sine 0 degrees is equal to 0. Now let us go for cos 0 degrees. Cos 0 degrees is AB upon AC. That means AB upon AC. But you know that AB and AC are equal, therefore it is AB by AB, that is 1, therefore cos 0 degrees is 1. Take tan 0 degrees. Tan 0 is BC by AB, and we know that BC is 0 and AB is what? AB is equal to AC, or we can take AB only. So it is 0 upon AB, that is 0. So tan 0 degrees is 0. So we have the values of sine 0, cos 0 and tan 0 degrees. Now take the reciprocal of sine 0 degrees, that is 0, 1 divided by 0 becomes infinite. So cosec 0 degrees is infinite. The value of cosec 0 degrees is infinite. Now cos 0 degrees is 1, reciprocal again remains 1, again sec 0 degrees is 1. Take the reciprocal of tan 0, that is 1 upon again infinite. So cot 0 degrees is value is infinite. So that is these are the values of the trigonometric ratios for the angle 0 degrees. Now let us go for trigonometric ratios of 90 degrees. Now in triangle ABC, if angle A is 90, that means angle A coincides with angle B, and AB becomes 0 and AC will be equal to BC. With this understanding, let us find out sine 90 degrees. Now sine 90 degrees is equal to BC upon AC, BC upon AC, but BC and AC are equal, therefore BC by BC becomes 1, sine 90 degrees is 1. Cos 90 degrees will be AB upon AC, but AB is 0, so cos 90 degrees will be 0 by AC, that is 0, so cos 90 degrees is equal to 0. Let us go for the tan 90 degrees. Tan 90 degrees will be BC upon AB, BC upon AB, BC upon AB, that is BC upon 0, because AB is 0, and therefore BC upon 0 becomes infinite, so tan 90 degrees is infinite. So these are the values for sine, cos and tan 90 degrees. Now let us go for cosec 90 degrees. Take reciprocal of sine 90 degrees. So sine 90 degrees is 1, and therefore cosec will be 1 by 1, 1 divided by 1, that is 1 only, and sec 90 degrees is 0, therefore sec 90 degrees will be infinite, because the reciprocal of cos 90 degrees is 1 by 0, and therefore sec 90 degrees will be infinite. Now take tan 90 degrees, it is infinite, and if you take the reciprocal of that becomes 0, therefore cot 90 degrees is equal to 0. So these are the values of the trigonometric ratios for different specific angles. Remember that. Now to remember all these values, it is not that easy. So I have given you a chart here which is called as the remembering chart for remembering the values of T ratios for different angles, that is 0 degrees, 30 degrees, 45 degrees, 60 degrees and 90 degrees. So you have to make this chart and try to remember this chart. Making this chart is very simple. Let me just explain you how to make this chart. First of all, write sine and cos here. Okay, then write 0, 1, 2, 3 and 4 in a increasing order, and then go for from right side 0, 1, 2, 3 and 4. Then divide each 0, 1, 2, 3, 4 by 4. Divide throughout by 4. Here also divide throughout by 4. Then take the square root. Everywhere. Now the chart is ready. Now if you want to find out sine 0 degrees we want. So 0 divided by 4 is 0. Therefore square root of 0 is 0. Sine 0 is 0. We want 30 degrees. Square root of 1 is 1. Square root of 4 is 2. Therefore sine 30 degrees is half. We want 45 degrees. Then 2 by 4 is 1 by 2 and square root of 1 by 2 is 1 by root 2. Therefore sine 45 degrees is 1 by root 2. We want 60 degrees. Square root of 3 by 4 is square root of 3 and square root of 4 is 2. So it is root 3 by 2. So sine 60 degrees is root 3 by 2. 4 by 4 is 1. Square root of 1 is 1. So sine 90 degrees is 1. So also we can find out the values of cos for all these angles. Now the question arises how to find out for other values. So very simple again. We know that sine by cos is tan. So find out the values of sine and cos. Divide sine by cos, will get tan. Now take cos by sine, will get cot. So that is how we can find out, and also how to find sec and cosec. Reciprocal of sine is cosec, reciprocal of cos is sec. So by just knowing this chart we can find out all the values of all the trigonometric ratios for any given angle, that is 0, 30, but these are specific angles. We cannot find out for other angles. These are only for specific angle. That is what is the study for us, and that is why I have given you this chart. So please remember this chart. Now coming to the complementary angles. Now two angles are complementary if the sum is 90 degrees. That is 30 degrees plus 60 degrees is equal to 90 degrees. Therefore 30 and 60 degrees are complementary angles. In a right angle triangle, angle B is 90 degrees. Angle A plus angle C is 90. Therefore angle A and angle C are complementary angles, or angle A plus angle C is equal to 90 degrees. Remember that. Now coming to the trigonometric ratios of complementary angles and their relation. In a right angle triangle ABC, angle B is 90, angle A and angle C are complementary angles, and that means angle A plus angle C is equal to 90 degrees. Now let us start with the one acute angle, that is angle A first. Now sine of angle A is BC by AC, cos of A will be AB by AC, and tan A will be BC by AB. And cosec A will be reciprocal of this, that is AC by BC, sec A will be AC by AB, and cot A will be what? AB by BC. Now that is for angle A. Now let us take angle C. Sin C is equal to sin C. Please understand, it is AB by AC. It is AB by AC. And AB by AC is what? AB by AC is cos A. It is cos A here, correct? But what is sin C? Sin C is 90 degrees minus A. See, 90 degrees minus A, because A plus C is 90. Therefore sin C will be 90 minus A. That is sin of 90 minus A is cos A. That means sine of the complementary angle of A, that is cos A. Now take cos C. Cos C is BC by AC. BC by AC, that is sin A. BC by AC is sin A. See, sin A. That means cos C is cos 90 minus A, that is sin A. That means cos of the complementary angle of A is sin A. Tan C is equal to AB by BC, and that is what? Cot A here, cot A. And therefore tan of 90 minus A is cot A. Tan of the complementary angle of A is cot A. And so also cosec A will be sec A. Cosec C will be equal to cosec C will be equal to cosec C. Cosec C, if you see here, cosec of 90 minus A is sec A, and sec C will be cosec A, or sec 90 minus A is cosec A. Cot C will be tan A. So this is what you have to remember. So the method is very simple. If you find the sine of complement of an angle, sine of complement of an angle is equal to cos of the angle. Sine of complement of an angle is equal to cos of the angle. Same way, cos of the complement of an angle is sine of the angle. Tan of complement of an angle is cot of the angle. Cosec of complement of the angle is sec of the angle. Sec complement of an angle is cosec of the angle. Cot complement of the angle is the tan of the angle. So these are very important relations which are useful for us for calculations in trigonometry. So try to remember these basics what I have have just discussed, and it is a very important basics which I have discussed here. Try to remember, try to make the chart, learn the chart, and very useful in calculations. I will be handling many examples related to these basics as a separate learning session, because that is where we will be learning, that is application of trigonometry, a very lengthy procedure, very many examples we can solve and learn, but basics are very important. Remember the basics first. If you remember the basics, then applications will be that easy. Thank you.